Hey, I'm glad you're back to listen to the second video. Not that I guess you really had a choice, but I hope it helps you. Here's the example I want to take a look at. We have an office building, has two elevators that start moving at exactly the same time. One elevator starts out 36 feet above the ground and is descending, and it's just going down at a rate of 2.3 feet per second. The other elevator starts out at ground level and rises, means it's going up, at a rate of 1.7 feet per second. When will the two elevators be at the exact same height? Now, as we take a look at this, the first clue that we have a system is that, well, they mentioned two things. It means two elevators. So each elevator has a starting point and a rate of speed. Kind of like slope and y-intercept from first semester, and it's exactly what we talked about then. So we're going to construct equations just like we did then. But we need to realize that we actually have two variables here. Let me show you how. The rate that is in both of the elevators is feet per second. All right. So you notice in the first elevator there's feet per second there, and then when we talk about the second elevator there's feet per second there. So it's feet per second there. Well, if we take a look at that, feet is in height, and the seconds is a unit of time. So we're really comparing height and time. All right? So we talk about time being independent. That means that height has to be dependent. The height depends on the time the elevator's been moving. And we know that, oh my goodness, independent is our x variable and dependent is our y. So what we can do is we can let our x represent the time in seconds, and we can let y represent the height of each elevator. So we're going to use that idea right here. I'm going to fold it up. Ooh, I must have pre-folded that or something. So we're going to use context clues to construct it. Let's look at elevator 1. So I'm going to highlight elevator 1. We have a rate, feet per second, and we have a starting. So what we need to do is we need to make sure that we remember y equals mx plus b, that's my rate of change and that's my starting amount. So we can have the height, remember y is the height of my first elevator. It's starting out at 36 feet and it is descending. So am I going to add or subtract? Yeah, that's right, we're going to subtract, and the rate is going to be 2.3 feet per second. And so second, remember, that is going to be my x variable. Mr. Mahalik, you got these reversed over here. Okay, so if you want to reverse them, reverse it, but I still have a rate of negative 2.3 because it's going down, and I have a starting amount, a y-intercept of a positive 36. So we look at the other elevator right there. I don't have a different color highlighter, so I'm going to underline it there. Alright, so let's do the same thing. Let's use the same variable, x and y. We have a starting height right there. It says it starts out at ground level. Ground level is a height of 0. And you can put the 0, you can leave it off, whatever. And it rises, so that means that I'm going to add, I'm going up. And 1.7 feet per second. So the speed demons go on elevator 1. It's faster, right? Even though it's going down, it's still faster. Alright, so guess what? Shazam, yay! This is our system of equations. We have two equations, two linear equations. They both have the same variables, x and y. Shazam, that's what we want. So, guess what we can do now? We can go back to our flowchart, which I probably can't find here. I probably threw it on the floor or something. Anyway, it says that we can go to our calculator. So, if we go to our calculator, we go to our y equal button, the first line we can put in elevator 1. There it is, right there. It's the same thing I just wrote down. And then we go to the next line. There's my elevator 2. No, I didn't put the plus 0 there. You can. It really doesn't matter. Now, if I want to see the graph, I'll see, hey, we're going to press zoom and 0. That's going to be a zoom fit, and we're going to get something like this. Now, if you look at this picture right here, we go, oh, yay, great, right here. That's our solution. That's where they cross. Great. The only problem is if you look at this screen, they don't tell me what is that ordered pair. Remember, we're looking for the ordered pair, the point where these two lines cross each other. So now, here's where the good stuff comes in. Now if you go to your table, all right, remember, when you look at a screen like this, you're looking at two ordered pairs. This first one right here is 6, 22.2, and then the other ordered pair is going to be 6, 10.2. So you have two ordered pairs. You got to know how to read this table, okay? But here is the gold right here. If you notice, when I look right there, on both of my equations, the output is the same. Now they're sharing an input of x. So on this one right here, this line has the ordered pair 9, 15.3, and this line right here also has the ordered pair 9, 15.3. Folks, they share the point. That means that's the solution. Now, a little bonus here. What does 9 represent? You remember? What does x represent? What were the two things we were comparing? You remember? I'll put this sheet back up here. We were comparing height and time. So my x value is the time. So these are my seconds. And this is my height in feet. So that means that the elevators were at the same height at 9 seconds. And the height was 15.3 feet off the ground. All right. Now, a little bonus before I leave you. All right. We got 3 minutes before I hit 10. Hey, this is the bonus keystrokes. This is your bonus for hanging around this long and listening to me yap. Okay. If you want to find the solution on the screen, I wonder if my calculator will allow me to, if y'all can see that on here. I'll turn mine on. Okay, so there we go. We got my calculator right here. This is the same problem we just talked about. Now, if I press my zoom 0, okay, hopefully it'll graph here. It's coming in. All right, there's the first line, and there's the second. Now, what you can do is you can use these keystrokes here, and what it'll do is it'll pop the solution up on your screen without going to the table. I know, that's so awesome. Here we go. Here's these are the buttons, right? I made these little things just for you. We're going to hit second, and then we're going to hit trace. Trace is right up here at the very top, okay? You hit trace, and what do we want to calculate? We want that intersection. We want to know where they cross, and we know they do. We saw the picture. We just want to know where. So we're going to hit 5, and they give you questions. Just blow that stuff off. Just hit enter 3 times. Enter, enter, and look at that. Shazam! Look down here. Look at the very bottom. The x value is 9 and the y value is 15.3, just like we talked about earlier. So you got a bonus. You might want to write some of this stuff down in your notes. I'm actually pretty proud of these videos. Well, I know. Maybe not as valuable as I thought, but I hope this helps. We'll do some more examples in class. Peace.